So, good evening, dear student. This problem on projectile has been asked in this year, 2021, in JEE Advanced paper number 1. So let us see this problem. In this problem, a projectile is thrown from a point O. From point O, a projectile is thrown with 5 root 2 meter per second at an angle of 45 degree. So at this highest point, it gets split up into two parts. That is the question. And this first part fall to the ground in 0.5 seconds. The first part has taken the time of 0.5 seconds. The second part, t second after the splitting, falls to the ground at a distance of x from point O. We need to find the value of t and x. That is the question. So let us see these questions once again. Okay. So in my view, this second part has moved. The first part is following like this. So in which direction the second part is actually moving, that is also the main concern. So let us see. At this point, if I can analyze, and before analyzing, let me find the some of the basic thing. Suppose ux means initial velocity in x direction, that will be 5 root 2 cos 45. I'm taking here also 45 because the angle with the vertical is also 45. So I can write that this will be 5 root 2 1 by root 2, so it will be 5 meter per second. And uy is also the same, 5 root 2 sine 45, so it will be 5 root 2 into 1 by root 2, that will be 5 meter per second. Okay. Now, so shall we find the time, how much time it has taken to go to the top level or the highest level? So let me find the time of ascent. So time of ascent will be u sine theta upon g. So let us see how much it will coming. So it will coming as 5 root 2 and it will be sine 45 and g is 10. So I can write as 10. So it will be coming as 0.5. In 0.5 seconds, it has reached to this point, up to this height. Okay. Now, at the highest point, the projectile got split up into two equal parts. And the first part fall vertically downward. First part, that will be m by 2 mass, fall vertically downward, and the other part will go in which direction, that we need to have concern. So let us see at this point of time, at this position, if I need to consider what the velocity of center of mass, so velocity of center of mass will be 5 meter per second in x direction. No. In y direction, velocity of center of mass does not have any velocity at this point of time, okay, at this position. So I can say that in x direction, as there is no external force acting, so total momentum of the system is conserved in x direction. So in absence of, I can write, in absence of any external force in x direction, total momentum of system is conserved. Conserved is constant. Conserved or constant. I can write that. So for this moment, for this position, I can write that um, m into Vx will be 5 meters, velocity of center of mass. I can write that. We are conserving the momentum, and we have 1 m by 2, and the first part is falling here only. So it does not have any x component of velocity, so I am writing here 0. And the second part, which I suppose that it has a velocity v, then the second part must move in this direction only to conserve the total momentum. The second part must move in this direction. Right? Yes. So From here I can see that m into 5, that will be m by 2 into vx. So vx is coming as 10 meter per second. So vx is coming as 10 meter per second. From here I can see that this vx is coming as 10 meter per second. So let us find some other interesting thing. So this part, which is m by 2, has taken about 0.5 seconds to come to down uh, to this ground. So this part also, because it is simple this way. So the mass which is moving with 10 meter per second, and it has a acceleration due to gravity in downward direction. So it will also take, because here uy component for this is also 0. So it will also take 0.5 seconds. So it will also take time equal to 0.5 seconds. That is the answer of first part. You can get this time by calculating the h also. If I need to calculate the h, suppose h equal to u square y upon 2b, and uy we have already found, it will be 5 by 5, and it will be 2 so it will be 5 by 4 meter. From here also we can find that time. So h is 5 by 4 meter. So from here UYT for second particle, we are finding this one. Half AYT square. So it will be H, that will be 5 by 4, and this will be UY is 0 for that also, and this will be 10 into T square. So T is, from here also you can see that T is coming as 1 by 2, that will be 0.5. T for this particle also time has been 0.5 seconds. So I will write the value of t at 0.5 seconds. What is the value of x from point 4? So let us see how to find this value of x. So if the ball or the particle has not split up, then the center of mass will go in this direction and okay. So if I find the range of center of mass. So range of center of mass, I can tell that u square sine 2 theta upon g. So u square, that will be 5 root 2 into 5 root 2 and sine 2 into 45, that will be sine 90 upon 10. So it is coming as 5 into 5 into 2 upon 10. Means if the particle has not been split up, then the center of mass will be landing at 5 meter from point O, but the particle has split up. So I can see that x center of mass, I can find out that x center of mass is m by 2 into this is our first particle, so I will write as x1, and this will be our second particle which is moving with velocity of 10 meters, so I will write as x2 upon m by 2 plus m by 2. Now for x1, I can see that from here also we can find the x1, because we have already find the time of descent, that will be 0.5 seconds. From here I can find the x1. X1 is nothing but that will be ux into t. So ux is your 5 and t 0.5, so it will be 2.5 meter. So x1 is 2.5 meter. So I can put that value of x1. So it will be 5, and it will be by 2. I have taken common, and x1 is 2.5, and x2 we need to find, and this will be m. So m and n get cancel out. So it will be 10 into 2.5 into 2. So x2 is coming as 7.5 meter. 7.5 meter for this particle. For this particle from here to here, is where it is actually landing. Actually, this is the trajectory of center of mass, but this will be the trajectory of that particle. This is going about will be 7.5 meter, and this will be our answer. Okay. So from here also you can find this the same thing. From here also, because we have already found this distance is 2.5 meter, and from here I can find the x also, then also we can get the same result. So this is our